Hello, and let's look at explaining the difference of two squares. There are several conditions that have to exist in order to have a difference of two squares. And then once we could diagnose that a problem that we're looking at is a difference of two squares, then I will show you how to go about factoring it. So first is that you need two terms and the minus sign. The second is you need to have even exponents on the letters. Or variables. The third is that we need to be able to take the square root of all the numbers evenly. And if we have all three of these conditions, then we have a difference of two squares. Before I move on, I want to go over how square roots work. So the word square in math implies the number 2. So for a square root, even though the number isn't shown, we could assume that it's a 2. And I'm just going to show you the pattern and then explain the pattern so you'll hopefully understand square roots. So the square root of 1 is 1 because 1 times 1 is equal to 1. The square root of 4 is equal to 2 because 2 times 2 is equal to 4. The square root of 9 is 3 because 3 times 3 is equal to 9. So hopefully you can start seeing the pattern here, and I'll explain it after I cover this one. Square root of 16 is 4 because 4 times 4 is equal to 16. So what's going on here is that this square here of 2 tells us how many times we have to carbon copy the answer by. So since our answer is 4, we have to carbon copy it and multiply it to get whatever the value that the root is on the inside. So the square root of 25 is 5 because 5 times 5 is equal to 25. The square root of 36 is 6, and so on and so forth. I recommend knowing maybe up to the square root of 169, which is 13. I recommend knowing all the square roots up to that point. Now, hopefully this will better illustrate what's going on with square roots. If I have the cube root of 8, that's equal to 2. Why? Because I have to take the answer 2 and carbon copy it 3 times to get to my solution 8. So notice the root now changes the carbon copying by 3 instead of by 2. Now another quick note about square roots is that you cannot have an even number root, or you cannot have a minus sign in an even number root. So for example is if we go back to say, well, we'll say the square root of 49 is 7 because 7 times 7 is equal to 49. Remember, the 2 is assumed to be there. So if the square root of 49 is 7, what would we assume that the square root of minus 49 will be? We would think it would be minus 7. However, if we take our answer and carbon copy it twice, a minus times a minus becomes a positive. Positive 49 and a minus 49 are not equal. So therefore, this doesn't work. You cannot have a minus sign in an even number root. That's where we have to deal with imaginary numbers. However, we could have a minus sign in an odd number root. So the cube root of 27 is 3 because 3 times 3 times 3 is equal to 27. And the cube root of minus 27 is minus 3 because minus 3 times minus 3 times minus 3 is equal to minus 27. So that works, having a minus sign in an odd number root, but you cannot have a minus sign in an even number root. So let's look at some examples here. So here's 4 examples that we'll cover. So let's look at this first example here, x squared minus 36. Does this meet the 3 conditions? I have 2 terms and a minus sign between 2 terms. So checkpoint 1 is met. Now we look at where all the letters or variables are. Do I have even exponents on them? 2 is even. What is even? 2, 4, 6, 8, 10, 12, and so on. And then can I take the square root of all the numbers evenly? I only have the 36 here. I could take the square root of 36, which is 6. So this is a difference of 2 squares. So what we would do is we would first show it as a minus and a plus. So whenever you have a difference of 2 squares, this is what you always do. Or you could show it as plus and minus. It really doesn't matter. So now we evenly divvy up the x squared among the first term as x and x. And then we evenly divvy up the 36 by multiplication into 6 and 6. The reason why multiplying these two binomials will give us 2 terms like this is because the O, which is this x and the 6, and the I part of the FOIL method, the I part would be this minus 6 and x. 6x minus 6x gives you 0. So all you're left with is the first part of the FOIL method, x times x, and the last part, minus 6 times 6, which is minus 36. So that's how you do that. Let's look at this problem right here, x to the 6 plus 36. I have 2 terms, an even exponent. I could take the square root of 36. However, there's a plus sign. You cannot have a plus sign. It has to be minus. So this is not a difference of 2 squares. It's not a difference of 2 squares. So let's take a look at this example. Let's see if this is a difference of 2 squares. Do I have 2 terms? Yes. Are they separated by a minus sign? Yes. So that is covered. Do I have even exponents on the letters? Yes, I do. Can I take the square root of all the numbers evenly? Could I take the square root of 4? Yes. Could I take the square root of 9? Yes. So these checkpoints are met. So because we have the difference of 2 squares, we show it as minus or plus, or since I showed it minus and plus here, I'll show it as opposite to show that it doesn't matter the order. So 4x squared, that's part of the first term, so that's going to go here. How do I evenly divvy up 4 by multiplication is 2 and 2. How do I evenly divvy up x squared as x and x? And how do I evenly divvy up 9? 3 and 3. And that's how we do that. It's as simple as that. Now there's some times where we have to go through a couple different levels of doing the difference of 2 squares. So x to the 4th minus 81, that is a difference of 2 squares. You have 2 terms with a minus sign, that's checkpoint 1. We have even exponents, and we could take the square root of the 81 evenly. So therefore, that's going to break down into x squared, show it as a minus and a plus or vice versa, and 81 could break down into 9 and 9. Now we're still not done because this x squared minus 9 is a difference of 2 squares. We have 2 terms separated by a minus sign, even exponents. I could take the square root of the 9. So I could break that down into minus and plus. X squared breaks down into x and x. 9 breaks down into 3 and 3. And then we have our original x squared plus 9, which is not a difference of 2 squares because it has that plus sign. So this is how you go about solving difference of 2 squares. Thank you.